Okay, thank you, gentlemen, for the really interesting papers. I'd like to start the Q&A session now. Right, we have a question in the room. Yes, David, please.
Thank you very much. This is really a question for Paul, but based on some things that Mike Pryce was saying. Were the RAF and the Ministry of Supply aware that the US was so far ahead with the B-36 and the B-47? And if so, how did that fit into the discussion of future policy? I mean, Mike Pryce's paper suggests that the UK was very clear that there was a new way of designing airplanes that was expensive, and that might lead to a leapfrog. Is that the answer to this conundrum of being so behind and yet continuing with this project? It seems rather mysterious to me what's going on here.
Yeah, the gentleman just asked about the knowledge of aircraft development in the state as to whether it's actually available within the UK government and the UK industry. I think it undoubtedly would have been, given the likely advertising of the American success with things like the B-36 and then the B-47. It, I think, is simply a question of the resources available, that the much more limited resources of the UK industry were spread relatively thinly across the various V-bomber types, and inevitably progress was slow. The American example of greater resource, perhaps focused more directly on a fewer number of types, was an example that unfortunately the UK did not follow. Possibly Mike would be able to offer a view on that as well.
With what became the Lightning, it was striking that what the British were trying to do was leapfrog the Americans. So the Americans were going for kind of transonic fighters at the time. Britain, it was kind of Mark 1.5, much faster. With the bombers, it's not something I've looked into in detail, but my understanding is that was a more important program, and the big issue was what does the bomb look like? It was a much harder problem to crack because the bomb you're going to carry wasn't entirely clear. Whereas with the fighter, the assumption was, well, you stick a couple of guns in it, and then later they added missiles. So they were very different problems. I think it was David Edgerton who was asking. The new approach to fighter design was a radical one for fighters. It wasn't immediately applied to bombers, but was obviously being applied in response to potential bombers in the future. The industry was very diverse. There were lots of ways of doing things. There were moves afoot in 1946-47 to nationalise the industry, which came to nothing. And that would have imposed kind of a standardised approach to designing, perhaps. That didn't happen. We had huge variety continue into the 1950s. It was only with Duncan's hands coming in that people looked to rationalise things.
Okay, thank you. We have the next question for Paul, the one that I just read before you joined. Right, you answer this one. How much was the post-war policy driven by politics preserving capability in industry rather than the RAF requirements?
I think the policy was fundamental and central, given the importance that was accorded to developing the nuclear deterrent and the means of delivering it. To an extent, I think the policy and the RAF requirements essentially became similar as Bomber Command's future really became focused on the delivery of the deterrent, with the V-bombers superseding the large fleets of piston engine aircraft. So I think it was a question of the RAF policy really meeting the official policy quite neatly.
Okay, thank you. Michael, was it that wind tunnels in the 1930s gave dubious answers, or was it the theorizing and use problematic? I did not hear that pre-war tunnels were flawed themselves, but I agree conclusions sometimes contradicted by later understanding. Interested in elaboration.
My understanding is the tunnels actually functioned properly in and of themselves. It's just that the results didn't scale up when you're using scale models to full-size aircraft. which is one of the reasons why they would often build a full-size aeroplane and put it in the wind tunnel. Various pictures, things like various Spitfires and other fighters at Farnborough. So the issue was, my understanding, was the scaling from scale models. So we found Reginald Mitchell's design, the Supermarine 224, if I remember rightly, that came before the Spitfire, that had problems. Typhoon famously had a wing section that was very thick based on wind tunnel data. That actually ran into compressibility problems when it actually flew. So there was this issue essentially of scaling.
Okay, thank you, Michael. Paul, you mentioned 5 different V-bomber types as being built and flown. I gather that you include, I gather that you include the Sperrin in this number, but what was your 5th type? Are you counting the Valiant in this number? And if not, what was the 5th type? Apologies if I have missed something.
No, nothing was missed, and the person who asked the question is absolutely correct. The 5th type I referred to was the Mark II version of the Vickers Valiant. I should have been a little more explicit during my talk. And it was interesting that there was such a multiplicity of designs that were not only proposed, but developed to the point of building prototypes. Arguably, I think the Sperrin was unnecessarily, it was extremely conservative in its approach. And it would have been sufficient, I think, to have had the Valiant as the insurance policy on the Victor and the Vulcan, and for the scarce resources to have been focused on the Valiant, so that in its Mark I form it could have come into service sooner. And the Valiant Mark II is also a very promising design, which arguably should have superseded the Valiant Mark I, while a decision was made to select either the Vulcan or the Victor, but not both.
Okay, perfect, thank you. We have a question to actually all of our 3 speakers. Are there any lessons from this period that the RAF government of today could learn in regards to policy around the development of new aircraft?
I think that could be taken up by Mike, as he was referring to it at the end of his presentation, and I know he has strong feelings on the subject.
Yeah, I express those feelings to the RAF now and again. Yes, I would say that often the lessons are something that emerges later on, outside this period. You can see that actually, in one way, you can see the infamous Duncan Sands White Paper in 1957 was a response to actually these things are taking too long and costing too much and being very specialised. And perhaps what we want is a different way. And that key lesson, I think, is that if you have a very focused design that pushes the boundaries of science, it will take a long time and cost a lot of money. And by the time it arrives, the world may have changed. So try to be quicker, and being quicker may mean being simpler. And that's the key lesson, I'd say.
And I think there's also an important point that you have to be ready to fail and fail fast. And if a particular concept doesn't work, that isn't total failure. You've actually developed your knowledge. You now know what is not feasible, and you can then move on to the next step. There is the scheme in the States, the so-called Digital Century series, in which it's proposed that on a 5-year cycle, industry will offer the best possible performance and capability that they can provide, as opposed to a 30-year plus period of development, which can sometimes end up in what's being termed analysis paralysis. We need to be quicker, because if we spend 30 years deciding what we want and then developing it, of course, by the time it appears, the world has changed.
There's always a trade-off with cost. The American approach at the moment is, in some ways, harking back to the past. It is very much saying use computers to work it all out in advance, which is what they were doing with what became the English Electric Lightning. Alan Turing's pilot ace computer was involved in that. But what they found was there are still problems of aerodynamics that you cannot work out with a computer. Things like when turbulent flows separate from airfoils, very arcane technical matters. But actually, there comes a point when you're designing a fighter, especially, because they have to turn very hard and therefore are prone to separated flows. There are still problems that can't be resolved until you fly them. So the issue of perhaps rather than trying to calculate everything in advance, but try and get something in the air and see what works, is an alternative approach. And that was traditionally how airplanes were designed up until this period.
Okay, thank you. And we've got another question, a general one. Did Britain conduct any espionage missions to steal US technology during this period? Was there any sharing of technology between the two nations?
If I could just jump in there, well, yeah, they would dump surplus Nazi engineers on each other. As far as I'm aware, although nuclear secrets were shut down at this time, lots of the aircraft design work was open. You had the pilot, the test pilot, Rowley Beamont, who first flew the Lightning, had first supposedly flown supersonic in an American Super Sabre. They were very open. He needed some supersonic experience, and he got it from American planes many years before the actual Lightning flew. There's lots of reports where engineers are touring American factories and just having open discussions with American designers from the UK of what they were doing. So they seem to be very open sharing of information. Certainly in the early part of this period, you found during the operations in Germany, a paperclip and so on, that often, yes, there'd be problems with the British would discover something and the Americans would nick it out from under their noses quite rapidly. But later on, the same information would often be shared. And I mentioned in my talk this thing called the relaxation technique. And what you can see there is it was originally created the concepts were created in the US and shared with the UK, and then the work went back to America. So the theoretical techniques were shared as well as the designs. But I'm not aware of any spying between the two, because it doesn't appear there needed to be any spying, because they were remarkably open in the design of airplanes.
I think there was also the occasion, and Mike probably almost certainly knows more about this than I do, the Miles M52 supersonic concept, that when it was cancelled, a lot of the design and research work was passed to the Americans, including the flying tail. Is that correct, Mike?
My understanding, again, I've read too much on this because lots been written. The fundamental difference between the two was the American design had a rocket and the British one had a jet. And jets lose thrust at altitude and rockets gain thrust. So the Americans took a kind of brute force and ignorance approach, which worked using a rocket, and the British were trying to be very sophisticated. And certainly one of the things I've got to get back to at some point is the information around the air intake design probably was flawed, and that could have been what killed the Miles M52. I know there's a book written by Winkle Brown where he said that essentially I couldn't find any problems with his design, we should have flown it. I think the flying tail was a common idea between countries based on when you look at compressibility, you can see that you need a flying tail to control the aircraft. But I'm not aware of the Americans having nicked anything. Bell started designing it before they were aware of it. But they all modelled them on bullets with wings at the time. That was what flies supersonic? A bullet. So let's make an airplane that's shaped like a bullet. But the propulsion system was the fundamental difference, and there they were absolutely different.
And the X1 and the M52 both used very thin wings with little or no sweep.
Yeah, and that's what Hans Multop was, like I said, evangelical in saying sweep was the thing. The Americans saw, once they saw the data, the big difference you found was that when they were going around Germany, the British brought data back to their state research establishment and then passed it on to industry. Whereas in the American case, you tended to have people from industry directly, almost in some cases, literally phoning back the design office of their company and saying, we've discovered a new way of making things for fast planes. Do this. There are examples, I think, from Boeing designing the B-47 bomber, where it was literally direct data from the German lab to the American design office and cutting out the middleman. And in Britain, we had a state middleman, effectively, Stafford Cripps and so on, and other people behind driving that.
Okay, thank you very much. One more question for Paul. As the V-bomber requirement called for £10,000, it is interesting that Vulcan ended up with a capability to carry 21,000 pound bombs. Is this due to having to have a bay volume to carry the nuclear weapons of the time, or could the Vulcan have been smaller and faster or longer ranged if it only met the spec of 10,000?
The 10,000 pound payload requirement referred specifically to the nuclear weapon, which was extremely bulky as well as being heavy. And the bombers proposed for the Vforce program, they had that secondary role of being used with conventional bombs, which a high bomb load in terms of 1,000 pounders was important. So the design required both that very large nuclear weapon to be carried and then a large number of conventional weapons as well. For example, the Victor could carry 35 1,000 pound bombs internally, which was a very high bomb load indeed. If that high conventional payload had not been a requirement, then I would imagine, yes, the aircraft could have been made that much smaller, and thereby with lower weight, lower drag for the same requirement to carry that 10,000 pound load to Moscow, the 1,500 nautical miles or so. To what extent that would have allowed the designs to have been smaller and lighter and thereby maybe a little cheaper, I don't know. I've never seen any figures on what that proportion might be.
Okay, thank you, Paul. Mike, one last question for you. Following your argument about cost versus capability and smaller fleets being driven by greater use of technology and therefore higher cost, could Western society ever accommodate or accept the Eastern preference of quantity being a quality of its own, given the exponential cost growth of high-tech quality?
I'm not sure what's meant by Western and Eastern here. I would say that, for example, the Second World War for Britain and for America was a production war. Quantity was pretty much everything. You had sort of small qualitative improvements, but it wasn't about radical innovation. Certainly, as Hermione Giffard highlighted that in her talk about jet engines earlier, how perhaps the Germans were throwing high tech at this because they were losing, and in the West you saw that if you wanted to win, you went for production. And even into the 1950s, so I mentioned at the end of the Hawker Hunter, that was produced in quite large numbers, funded, half of them paid for by the Americans, because the Americans believed in large volumes, and buying aircraft built in Britain was cheaper than American aircraft, so you got larger numbers by funding a foreign power, a kind of an unusual situation compared to today in lots of ways. So I think yes, we could go back to, if we chose to, we could go back to what we wanted in the past, which was quantity, and not with this obsessive focus on quality. The focus on quality has led to increased cost and reduced numbers. There's lots of talk at the moment in public debates around combat mass. How do we get more airplanes? Well, you get more in part by making them cheaper. How do you make them cheaper? Perhaps by making them less capable. And then people lose their minds because they're fearful that if it's less capable, we'll lose the war. But if you look what's actually been used since the Second World War, since this period, it's hard to see any high-performance aircraft using its maximum performance in a combat mission. They're often just kind of lumbering around using their sensors, but flying at relatively subsonic speed, dropping bombs in a fairly straightforward manner, using the targeting system to deliver the performance, not the actual speed. So yes, I think you could have simpler platforms with more sophisticated weapons and sensors bolted on as needed.
It is notable that the two British combat aircraft types that have been most successful in export terms since World War II have been the Canberra and the Hunter, and those were relatively simple. Maybe not with their immediate contemporaries, but certainly in later years, when you look at the leading edge designs such as the English Electric Lightning, which had really quite limited export sales, certainly compared to the Mirage 3 and 5 series, there's no comparison. Or the Super Sabre, for example, which sold by several thousand units. So I strongly agree with Mike on that point. Sort of the leading edge capability will often price you out of the market, and yet it's a capability, certainly in performance terms, it's rarely used.
Okay, thank you. Did the US ever consider using the English Electric Lightning? Is the last question here.
No. Simple answer. Not I'm aware of. Some exchange pilots flew it and they liked it. British aircraft usually handled much better than American aircraft, so you could fly it to the sort of edge of the envelope with less fear of crashing. Although plenty of Lightnings did crash, than you would with American fighters. It was just a feature of how Britain developed aircraft, and the design requirements meant that often the handling for a pilot was better. So they liked flying them, but they at no point looked into buying them.
The Lightning was remarkable for having very, very high performance indeed, but apparently it was really quite benign in handling terms, relatively speaking, compared to some of the American types, as Mike's referred to. Lightnings were lost, mainly because they kept bursting into flames in midair. Essentially, they were just two Avon engines with a fuselage wrapped as tightly around them as possible. And they also leaked like sieves, apparently. Certainly, some of the older chief techs and flight sergeants I worked with when I was in the Air Force would refer to a typical Lightning as just sitting on the ground surrounded by drip trays to catch all the fuel leaking out. And of course, it had a very, very limited range and endurance. It was essentially, in some ways, a research aircraft that was developed into a fighter. And it started off with that handicap of limited fuel volume, which proved really impossible to overcome.
All right, thank you very much. Well, I think we are running short of time right now. So thank you very much for the really interesting, absolutely great panel. Yeah, and I think next one is the poster of Abby with Fox. So yes, ladies and gentlemen, please join me in thanking our three speakers, at least, well, virtually, for the great session. Thank you very much.